Hi there and welcome to this revision talk on the visual pathway. Sometimes it can be a bit confusing, but hopefully this will simplify things so you can always remember it. Okay. So let's give you a couple of rules to try and make it easier. A general rule about the cerebral hemispheres. Well, the left senses and controls the right side of the body and vice versa. And we've seen that from the talks from Sue and Paul. And our sense of sight is no different. However, two things do make it a bit more complicated. The first is the camera-like optics of the eye itself, and the second is the visual fields of each individual eye across the midline. So let's have a look at the first bit first. Remember from O-level physics about the pinhole camera? So here we have a pinhole in our camera and an image that it's looking at. The light from one end of the image goes through the pinhole and can form an image on the opposite side of the back of the camera, and the same thing from the, say, the legs of this lying down body to the side. So you'll see the image on the back of the pinhole camera is inverted. So the head is at the opposite end to the actual image or the actual object itself. And the eye is no different. The only difference is rather than having a pinhole accepting the image into the eye, we have a lens and the cornea. But exactly the same thing. The image on the back of our eye is inverted. So then we've also got two eyes rather than just one. So that does make it more complicated. And as we can see, if we draw a line down the midline, the image from one eye from the object covers the midline. So here we can see the image on the right hand side of the midline will go to the left eye or part of it, and the image from the right hand side will go to the right eye as well. So each eye receives light from an image on either side of both sides of the midline. So that makes it a bit more complicated as well. So if we just look at that in slightly more detail, here in this red shaded area, the imaging from the right side of the midline is going to the lateral part of the retina on the opposite eye, on the contralateral eye, whereas the light from the right hand side of the image is going to the medial or inner surface of the ipsilateral eye, the eye on the same side. And this represents the retina at the back. And if we look at the blue, then the blue does the opposite. So, but you can see the blue light from this left hand side of the object is going to the lateral surface of the contralateral retina and eye, and the light from the left side of the blue light, the left side of the image of the object, sorry, is going to the inner medial surface of the retina on the same side or ipsilateral side. And again, each eye has the image inverted, but each eye is getting a complete image of the object on both sides of the midline. So remember that rule about the cerebral hemispheres. The left side senses and controls the right side of the body and vice versa. So somehow we've got to have the image being created by this eye split so that the blue part of the image is going to the right side of the brain, and the red shaded part of the image from the right side is going to the opposite side of the brain. If you can remember that, you can work out how it works. So let's go into that in a little bit more detail. let's have a look at the red side of the image. So the right side of the image is striking, the photons of light are striking the retina on the outside of the opposite left eye, going through a neural pathway and staying on that left-hand side of the brain. So this light is being reviewed by the opposite side of the brain. And you can see how it's going to the opposite side. This red light going to the eye on the same side, the right eye, is coming down the neural pathway, and see how it's crossing across the midline to go to the opposite side. So the light from the right hand side might be stimulating both eyes, but because of this crossing over, it's all being received and interpreted by the opposite side of the brain. So that rule which we said about the left side senses and controls the opposite side applies here. And if we add in the blue part's doing the same thing. The blue light from the left side of the image is being stimulating the lateral portion of this retina, which is staying on this side, and the blue portion, the medial portion of the eye on the same side, this neural pathway is crossing over. So the blue light from the left hand side is being interpreted by the opposite side of the brain. And here you can see our image again is inverted, switched round. So that's really fundamental. If you can understand how this pathway works, you can understand and work out from first principles what sort of problems you might see. So rather than my rather crude diagrams on my pieces of paper, we've got one of Charlie's really elegant diagrams. I think somebody else drew the picture at the front there. So here we can see a similar principle, and we've got different parts of the visual pathway. So we've got the eyes. Let's just draw those in detail. We have the eye and the sensing organ, the retina. The nerves go through the optic nerve. Here at the optic chiasma, the nerves from the lateral retina carry on the same side, whereas the nerves from the medial retina cross over at the optic chiasma. And you can see them crossing over the opposite side. Beyond, further posterior to the optic chiasma, we have the optic tract. Then you've got your lateral genital bodies. Through the brain itself, you have the optic radiation. At the very back, you have the visual cortex. So why are we teaching this? Well, again, we're teaching how to be doctors rather than pure anatomists. And if you understand this pathway, then when patients present with different patterns of sight loss, you can work out where the injury or the disease process may be. So let's look at that in slightly more detail. Well, we've laboured the fact about normal vision coming from both eyes. So here's got the image from the left eye and image from the right eye of Van Gogh's self-portrait. That's normal vision. If we take an injury through the optic nerve, let's say position 1, then you will lose all vision in that eye. And you can demonstrate that just by covering one eye. It removes blank. And that's a monocular loss of vision. If we have an injury slightly further back, here in position number 2, a across the optic chiasma, then you'll get what we call a bilateral. It's going to be on both sides. You can see how this is receiving images or neural stimulation from the inside of both eyes, the medial retina of both eyes. And you see how the medial retina is actually taking photons of light from the lateral portions of the image. Okay? So you can get loss of vision from bilateral out to the sides. And we call that a bilateral temporal hemianopia. Temporal meaning out towards the side, and hemi meaning half, anopia meaning loss of vision. And you can see the pattern of pressure or disease process affecting the optic chiasma will give you a bilateral temporal hemianopia. Hopefully you can understand that, that's quite crucial. Well, what disease processes can do that? Well, if you remember our anatomy, the pituitary gland sits just at the base of the cerebral hemispheres and sits right up against the optic chiasma. So if you have a pituitary tumour, and they're relatively common, that can put pressure on the optic chiasma and give you a bilateral temporal hemianopia. So, if we have a disease process further back behind the optic chiasma, either in the optic tract, the lateral nucleus, or the optic radiation or visual cortex, we will get loss of sight on the contralateral side, or the opposite side, but it's going to be completely on that opposite side. So that's why we call it homonymous hemianopia. Still half a visual field, but it's a complete side. So here you can see we've lost the whole of this side of Van Gogh. It's been cut off, a bit like his ear, because the site of disease or injury process is posterior to the optic chiasma. And that's a contralateral homonymous hemianopia. So let's summarise that, okay? If we can remember that the left brain senses and controls the right side of the body and vice versa, we need to remember the pinhole camera inverting the image. In fact, we've got two pinhole cameras, which is how our eyes work, and somehow we've got to get the image from the right side of the midline across to the left brain, and the left side of the midline across to the right brain. And it does that by the optic chiasma in the middle, taking the medial fibres from the medial portion of the eye across the opposite side at the optic chiasma. Remember this pathway, then an injury at different levels of this pathway will cause a different pattern of sight loss. So good luck, and I hope it all goes well. Remember the basics. Take care. Bye-bye.